Hello, everyone, and welcome to Session 3, Track 2 of the Minnesota ASQC 2020 Conference. My name is Georgianne Keyport, and I'm happy to introduce this session. This recorded presentation will run about 45 minutes and will include a live Q&A session with your speaker for the last 15 minutes. We encourage all your questions and comments, and so we ask that you submit them throughout the presentation using the session's Q&A box, and the speaker will respond to your questions during that live Q&A. We ask that you use the session's Q&A box rather than the chat box. During the presentation, all participants are in listen mode only. And now I'd like to introduce our speaker for this session. Perry Perendo began developing and seeing results from his design of experiments techniques at the General Motors Research Lab in 1986. His unique insights into design of experiments have saved time and money while solving complex problems during product and process development. This paved the way for him to lead multi-million-dollar new product development projects with international teams. Perry founded Perry Solutions, LLC in 2006 to help organizations with critical product development activities. He has consulted in a wide range of industries such as consumer products, biomedical products, and heavy equipment. He received his mechanical engineering degree from the University of Minnesota. He has presented at the Minnesota Quality Conference multiple times over the last 2 decades. Please help me give a virtual big welcome to our speaker, Perry Perendo.
So one day my boss comes into my office and he tells me that he's heard about an issue with one of our customers and wanted me to be on top of it or be aware of it. And it wasn't much longer than that, I got a call from the customer myself, and they were expressing their concern with this product that we had. I did a little digging with some of my coworkers and went to the manufacturing floor to learn a little bit more what they might know about it. Went back to my boss and I said, it looks like it's going to take a certain amount of time. I need some people, need some materials to do that. And the response back was, well, can't you do it with what you already have? I think for a lot of us, when we're trying to implement improvement projects, I think we have that same problem where we need resources and we don't have them. So that's the genesis of today's conversation, is to talk about how do we resource those improvement projects, get what we need, and yet still solve the problems. So today what we're going to walk through is how do you triage improvement projects. Probably the best way to resource things is to say no to certain things that really aren't that important, or at least lesser important than others. Help you justify the resources and schedule requirements you have as things evolve. When you're doing problem solving, sometimes things get more complex, they get a little bit easier, and we're going to just how do you work with that moving target. We'll talk about how to prioritize your individual as well as your team workload, and ultimately, bottom line is, how do you avoid being overwhelmed as an improvement leader? So some examples of improvement projects that really are covered with this. It could be something which is pretty common to a lot of us, the corrective and preventive action, or CAPA process. It could be some type of CAPA issue. It could be a manufacturing yield issue. Things were going good for a while, all of a sudden there's a slip in performance, and we're not able to meet customer shipments or things like that. Maybe it's like the situation I laid out at the beginning. It's some field issue, a customer complaint. Maybe it's gone as far as where it's an actual recall, and it's very visible with maybe a regulatory body or something like that. In the last example, it could be even upstream in the development process, a design issue that you're not progressing on, or maybe a new manufacturing process you're trying to evolve that's not meeting expectations. Any of those would be unexpected improvement projects that basically aren't budgeted and aren't resourced. So if one of those apply to you, that's certainly what we're going to be talking about in the next hour. So the typical approach when we have a situation like that is the issues identified. And again, the case that I started with, kind of the boss identified it to me, but ultimately it came from a customer complaint. The owner's established. That happened when my boss walked into my office and told me, hey, this customer's mad and they're going to be calling, expect it, you're in charge. And then a lot of times, particularly in the CAPA processes, there's pressure to close out by a certain standard date. The companies I work with my consulting work, and when I worked in corporate, there tended to be a 3-day or 1 week standard date to basically close out the issue, to figure things out. A lot of times as you're digging into it, it's really a specific issue with special conditions. This wasn't found during initial development or initial manufacturing, or even initially by the customer. So there's a lot of details and a lot of very specific special things that you need to work through to really solve that problem. But oftentimes, because we're rushed with that pressure to that standard closeout date, and frankly, a lot of managers are rewarded for closing out things, leaving things open is considered a negative. We end up dealing with the symptoms of whatever that customer identified issue was. If we sense the scope was bigger, we'd need team and resources. But that's usually not within that closeout schedule, and it's certainly not within the expected budget that the boss had, which is no budget or resources, because we should be able to absorb this in what we do on a daily basis. Going through this typical process obviously means we don't really solve it. We're dealing with symptoms without resources. We're just trying to close them out quickly just to kind of check the box. And that's frustrating as a quality professional or a project leader or manager to live in this type of environment. We want to do better. How can we best do that? Again, some of the challenges with that typical process, things I think impact our ability to perform as well as we'd like. It really starts with verifying the problem exists in the first place. Too often we assume the customer's right when they say there's a problem. There's the old mantra of the customer's always right, and we got to be careful how we do that. But sometimes the customers observe something, maybe they're using the wrong language, and they're using a language that makes us think of one thing, but it's actually a different problem that's actually happening. Or maybe it's being used improperly. I think we'd need to replicate the problem and just kind of basically deeply understand the problem before jumping to here's how it's defined by the customer phone call or my boss coming into my office. That might not be the accurate description of what's really going on. Once we do verify the problem and know what's going on, there's certainly the uncertainty of when it's going to be solved. How big of a challenge is this that's in front of us? And I think as a manager, there's the hope, hopefully we can resolve this tomorrow. But the reality is sometimes these things could take months of digging and talking to vendors and so on. And if we do go through and figure it all out and implement these changes, does it even make a difference? Does it really matter? Is there going to be an impact if we resolve this? Was this 1 in 1,000 or 1 in a million chance and we only make 100 a year? We need to understand that we're basically working on things that are going to make an impact for the organization and for the customer. And kind of related to all this, is it a simple fix or a complex fix? In distinguishing those, I think early on helps us get the resources we need. If they're always assumed to all be simple fixes, then we're never going to get resources. And so we need to kind of distinguish between those two to help us move forward. So one of the solutions to this, I'll call it estimating incrementally. And so instead of on day one saying this is going to be a 3-day or 3-month effort, we just don't know enough yet. I think we can start with when that boss walks in the office, that we can basically do some initial planning. That's step one, or step zero almost. It's not going to have any budget associated with it. It's part of my normal workload because, hey, there's going to be a phone call from a customer, but I can give a target date of when at least that initial planning of what's going on and what it, just again, the initial planning of what I can see from day one, boss conversation, customer conversation. But we can have a hard date of when we expect that to be completed. If we're currently buried within other things, that target date might not be in 3 days, it might be in a week, because we got a crisis that we're already working on. So communicating that target date, not in a standard 3 days or 1 day, but based on our current workload. The second incremental step is some initial research. Again, there's no budget to it. We're absorbing this in what we do daily. It's part of our job and part of our normal scope. But again, we have a target date. Maybe we need to evaluate a couple of prototypes, and not anything complex with that, but take a look at it, play with a couple parts. Maybe we need to look at some data in a database, and the person with that access that database is on vacation, or they're consumed for a certain amount of time. So again, just some of that, it goes beyond the initial planning of what we can see to doing a little bit more in-depth research into what the situation is. So again, a target date for that. At that point, we should know if we're in a simple or complex situation. And as we define those situations with our initial research, we have some ideas. This really look like it's going to be a simple thing to solve. And now we know that we're going to need to build a couple of sample parts, or we maybe need some computer simulation, whatever it might be. It's going to be a pretty simple budget, and a pretty short-term target date again. However, if we've looked through that initial research, it's more of a complicated situation. There's multiple potential variables that could be causing our situation. Now we're going to have a healthier budget and target date. I recommend, if it's a complex situation, and the one I was talking about earlier with the customer calling me, it ended up being a complex situation. I recommend planning that first design of experiments. That's a way to estimate the labor, the resources required, any materials you might need. If it's a production situation, they don't like taking production parts away because they were planned for other things. So those things need to be negotiated. It may change some vendor orders and things, a lot of things that could impact that. But you plan that first DOE, and we'll talk more about that. But that allows you to do some detailed planning, including potentially production operators that need to be involved, customer communication, a lot of feedback that could be involved. It allows you to understand what it's going to take to execute the test, as well as analyze the test data. What's your plan for that analysis? And then based on that scope of those first three sub-bullets, then you add some sort of multiplier, and we'll talk about this more, based on the complexity or the verification test that you end up having in front of you. And then once that solution is in place, only then can we really determine what our implementation plan would be, and any resources and materials and target dates for that as well. But you really can't define an implementation plan until you know what the solution is. You don't know what the solution is until you know if it's a simple or complex situation. So you really need, you kind of give the next increment of what to expect, budget or date wise, as you go through those bullets on this slide. Again, I kind of hinted up early on, defining the problem isn't enough. We really need to understand the problem. Again, a customer may make some kind of complaint and observation, but from us working with it in a more detailed day-to-day basis, what they may have said, they may say something's leaking, but it's really not leaking. It's maybe some other failure mode that's actually more appropriate. I would caution to beware of solving I call the obvious problem instead of the true problem. So that's part of, again, understanding the true problem and not just taking the initial definition from the customer or in the CAPA is what we actually try to go fix. Sometimes that happens and the customer still sees what they were seeing before because we didn't really understand what they meant. So the first sub-bullet to all that, is there even a technical problem at all? Again, we should really replicate it. I've already talked about this, but some customer complaints may need to ensure that the language that they're using matches how we use those phrases, and that we don't jump to conclusion of what they mean by what they said or what they observed. Because we're experts in our product, we need to verify what they're seeing just to make sure, again, it's totally understood and it's reproducible, so we can make sure we know that went away. It could be a communication or a use problem. Is it a reasonable, unexpected use? I'm not a lawyer, but I know kind of in the legal sense, it's not so much that customers misuse it compared to our expectations, but is it reasonable that they could use it in an unexpected way, which sounds kind of contradictory, but if customers are using it in an unexpected way, but we could expect it, we're still liable for that activity, is how I understand a lot of cases that go through. So it's not just they're using it different than we imply. We need to make sure, even if they use it incorrectly, that it's still safe and performs appropriately. So that's part of that problem understanding, which I think is essential for getting started. Problem complexity. I talked about in that flow chart of incremental planning. We need to define if it's a simple or a complex problem. If it's a simple problem, then there's some simple tools that can uncover and help prove that. And I have a YouTube channel with some supporting information on what I mean by simple tools. I call them the 7 simple tools. You can see the link on this slide, YouTube link, that's part of my channel that talks about those. Most of my videos out there are 3-4 minutes to kind of give some sample background on different topics. If it's a more complex problem, then we're going to need more resources. It may need some advanced approaches. And again, what do I mean by that? What are some of the things there? We don't have time in our hour today to go through that. But I have another video talking about root cause analysis, and the intent there is more complex problems. And so I have another YouTube video on my channel, and so you can see a link to that as well. If it's a more complex problem, what I would call more of a root cause analysis, there's several different ways that we can estimate what effort is going to go into things. I kind of gave you a DOE bottoms up type look, and that's good for fairly things that you can get your arm around. If they're much bigger issues, which we'll see more in R&D type efforts, and R&D can be for a product or a manufacturing process, but there's some other more simple, quick things for estimating our effort. And so the first one is an argument of similarity. We've done a project like this, it's very similar to that. That one took 2 months and 10 people and $10,000 or whatever it might be, and so this one should be the same. The next approach for estimating is a comparative approach, which on the surface sounds like the similarity idea, but instead of, we did this one project before, now this new project, let's say, is twice as much as that project we did before. And because we know project A, what actually happens, we're going to double everything. Or maybe it's only half as complicated, or maybe it's 3 times as complicated. Those comparative, somewhat closely comparative examples can be a good way to scope things. And so again, if the boss says to us, can't you do it with what you already have? Here's the argument of, well, remember project A? Remember what happened there? And that can be kind of not just providing the estimate, but also providing the story and the justification or basis for why we can't do it with what we already have available to us. There's also some more advanced parametric models, which is basically a software tool, but it's looking at high-level parameters instead of looking at every nut and bolt you might need to prepare a test. It's some ways to do some resource and cost estimating at a very, very high level. Those may be appropriate for very complex situations. Another approach is expert opinion. Someone that's done this stuff for years on this type of product, they might be able to look at something and again, just jump to that's a 1 month, 3-person effort for a month, for that month. You may hear any of those options for estimating and think, well, I don't like that one, or that one doesn't sound very good. And you're probably right. I think the best thing is a combination of those items. Maybe you do a similarity argument and then an expert that not verifies it, but has an opinion that matches. So I think doing multiple simple efforts for estimating, if they're matching in the same ballpark, is very useful and can help you tell that story to justify your resources. Remember though, because I see this with a lot of engineers, we got to remember that there's I'll call it engineering and labor effort, but there's also the calendar duration. I've seen some cases where the boss comes to the employee and says, hey, we have this problem, how long is it going to take? And they say, well, it's going to take me 2 days. And they say, well, great. Okay. The boss comes back in 2 days, and the employee says, well, it's not done yet because I need to get this tool made, and the tool takes 3 weeks. Well, yeah, it only takes 2 or 3 days of your effort, but what's the calendar impact? When are we going to get the tool in? And that's where the target date comes into play. So it might only take 2 days of labor effort from you, but what's the calendar time to get the new tool in or get the prototype parts in, whatever is that calendar duration as well. So remember, with all of our estimates, we need both the effort, so-called effort, and duration that's involved. And I think doing that will help your estimating and justification. I talked earlier about design your first DOE and then use some multiplier. Here's some rules of thumb for estimating if you're able to scope that first DOE. And in my consulting work, that's how I'm able to bid on projects with companies that call me. It's usually an emergency situation. If it's a recall or a yield issue. But I talk to them enough to scope out that first DOE. We don't know what's going to happen next or what the results of the DOE would be, but I try and sense where they're at on the scale on this slide. If it sounds like something we've really done before, maybe we're just verifying a simple solution, it's really not a full DOE, there's going to be some things that are beyond the scope of that verification test, I'll call it. And so I usually multiply that by 1 1/4, because what I can foresee is going to be close, but there's going to be some incremental things that notch that up. If it's going to be similar to stuff we've done before, but with some changes, then I'm going to double that DOE. We may not repeat the whole thing, but we may repeat a portion. There may be some verification efforts involved. So I'll take that first DOE and double it. If it's really a new idea and it's kind of like early stage R&D type effort, again on the product or process side, there's a rule of thumb in DOE that you can multiply by 4 for a brand new idea. Basically, if you have very limited, almost no knowledge of a situation. So I give you some idea of how to scope with just knowing the initial phase and how to kind of project the future efforts that you might have. If you're curious about how to set up a DOE, I have another YouTube video and obviously that link on this page as well. And I'll talk about real quickly some of the key steps in setting up a DOE so that you can use these multipliers to scope your resources. Then we want to talk a little bit about your workload impact. What are some options to gaining resources? The first one, and it's often employees don't like doing this, but I think pushing back on the boss and saying, hey, I need to delay project A to be able to do this quickly, or I can't do what you asked me to do until this other project is done. And I think it's very important not to just say I can't or to give them some bad estimate. Communicate specifically what's moving out and for how long, either the current request or a prior request. You can certainly gain resources by getting help from others, either just absorbing in what they do or getting more of a commitment from them. And then clearly finding outside resources outside the company that can assist and give you some of that bandwidth to address the issue. There's likely some level of no resource tasks that can be absorbed in a given period of time. So for example, if you're working on 4 simultaneous simple tasks and you're defining the project for those, that can be absorbed by one person along with other duties. However, if all of a sudden there's 4 simple projects going on, or project definitions that kind of jumped in as far as a kappa maybe, you can't work on more than those 4. So if 10 come in, 6 of those 10 have got to be delayed, let's say for a week, until you've absorbed those other 4. And then identify those 4, simultaneously agree on what they are. I also think it's important to understand the risk that's generated by the solution before we implement, understanding not just what the solution is, but any risks to that. How does what's currently going on, the early stage of problem definition, or even when you do find the solution, do we keep building? How's this going to impact the supply chain? Do we keep building stuff internally and shipping it? Do our suppliers keep shipping to us? Are we going to maybe need to change suppliers? Do we put things on hold? There's a lot of questions on there. Should we tell our customers to keep using what's in their inventory, or should they stop using it? If you kind of put in that solution that problem returns, that's really bad news. We want to find a solution that really sticks for quote unquote forever. We don't want to implement a solution and the problem come back next month or next year, because obviously for a customer, there's only so long they're going to tolerate that. And it may not be for that particular product, but it might be for new products and new designs that they might be locked into what you currently are selling, but they won't purchase the next product that you're developing. And again, more on implementation risk or solution risk. What are the technical risks of that solution being achieved? How complex is your current situation? Do we have the skills in-house, and members of the team already that can do this? Do we have the knowledge of this product or of the tools we need to use? Are the resources that we do have, we may have skills, but they may not be available as deeply, as many hours as necessary. How can we rebalance all those things? Also, there's some business risk associated with this. Sometimes in a kappa situation, we're going to do something short term, but then, there's a longer term solution we could put in place. But will our customers actually accept that short term solution? If not, let's not waste our resources on that short term solution, focus only on the long term. And sometimes that's the right answer, is let's only provide the long term solution, because the short term, no one likes it. It's really not any better than what we're currently dealing with. And kind of another question, business risk. Can they temporarily handle the current situation? Can they live with how it is now with no short-term solution? And that is our short-term solution. So those are a lot of things that, as an engineer or quality professional, we may not have those answers readily at hand. So again, it's kind of a management and a customer that needs to confirm or reject our short-term and long-term solution path, or if they can temporarily handle what they're currently experiencing. Again, some of the manufacturing options for, if the product related issue, consider the short-term and long-term solutions in manufacturing as well. What's the impact or complexity or confusion goes in with that. Short-term solutions may be less than ideal, but typically several options exist there. But it may not be very efficient to produce it. Our yields might be low. It might cost too much because we're putting extra glue or we're doing something to secure something that's just very, very labor intensive that wasn't labor intensive before. But our long-term solutions may take too long as well. The customer won't wait that long to get that solution. Again, I think long-term solutions, there's several options that can exist there. But another question I think we need to ask, because sometimes that solution might not be with changing the current product, I think we need to ask if there's enough life remaining in the product that we have to justify the investment, which is kind of a business decision too, but manufacturing may have more insights into that than maybe some others. But if you're only going to sell the product for another 6 months, is it worth justifying some investment to quote unquote get a longer term fix maybe in a month or two from now? The product's being obsoleted, so let's just live with how it is now. So again, this means we need to estimate resource and material wise the short-term solutions, long-term solutions, be clear of what's included, not included in those estimates, so we can make those good business decisions and then decide what opportunities and path forward that we want to discuss with the customers to get their buy-in. So everyone's aligned, but it's our manufacturing, our design, our business, and our customer aspects of a more complex solution. Again, to make sure we implement things that people want. Again, we kind of talked about this already, but this business option, maybe we want to just live with what we have for now, and the new product that's in our pipeline is actually going to resolve it. So why do we want to put in and implement a solution with resources that weren't budgeted now on an old product when this new product's coming along and it's going to obsolete that one in 6 months? So not only is the old one going to probably die off, this new one's going to actually fix the issue. And that's probably an important aspect as well. If we realize it's an issue with the old product, is our new product's going to fix that, or are they going to have the same problem? If they're going to have the same problem, even if we fix the old one, make sure the new product gets that solution implemented as well. Again, this is a huge business decision. We want to evaluate the trade-offs of our resource use on a temporary, short-term CAPA type project, or use those for longer-term projects, which have a struggle as it is to get finished on time and finished well. So let's not make sure we're diverting resources that are going to further delay that new product from solving that problem. So the takeaways from the discussion we just had, so there's a lot of aspects to it. It starts with the takeaways from today, verifying that your problem exists. That's that first increment of activity that we talked about. We want to understand the problem, again, giving these target dates for when we're going to verify it, but before we start saying how many resources it's going to be or that it'll be solved by Friday, again, verify the problem, understand the problem first. And then as we walk through the uncertainty and we get more clarity as we go through that problem solving process, we have a better idea of when it can be resolved, and then incrementally what resources can be required to get us through that. Again, we define those expectations for resolution after some short period of time versus day one when the boss came into my office, or within a standard 3-day time frame. Again, if you're getting hammered with 10 different CAPAs on the same day, you're not going to be able to get those through in the standard lead time of 3 days or whatever your organization might have. Again, another takeaway is understand the impact of the changes. Is this worth our time? Can we really scope the time? should it be done now or not? How does this all play into some of the business decisions that we have going on? And then again, how does this relate to the customer's acceptance of short-term, long-term, new product type answers? So there's a lot of conversations in more complex situations that we need to make sure and have in our hands. And again, the last takeaway is something I mentioned early on, but is the kind of that split of the solution, which is this a simple fix or is it a more complex fit? If it's a simple fix, a lot of the stuff I talked about today isn't a big deal, but it's the 1 in 10 or 2 out of 10 that start leaning down this more complex fix. And I think sometimes we may jump to conclusions things are simple fixes when they really shouldn't be, but it's just to get it off our plate and ignore, be done with it. But if it's a simple fix when it shouldn't be, it's just going to come back. So instead of jumping to those conclusions, again, it's deferring 6 out of those 10 that show up on the same day, so we make sure and give adequate attention to those 4. We get those 6 off our plate by saying they're lower priority. Let's focus on these 4 today. And again, it allows for us to position our discussions for follow-up with, again, customers, management, our team, whoever might be involved in really understanding those issues and those situations so we can address those properly. So that wraps up the prepared portion for today. I gave you a few YouTube channel links that could help give you a little more depth in a couple of areas that I didn't think we had time to explore in depth today, or you may already be familiar with. Really want to focus on more of the soft skill of finding resources versus the hard skills of the tools that might be involved in resolving those issues. If there's questions you have, certainly feel free. I mean, obviously we're going to discuss things now, but if offline something comes to you, feel free to call me. That's my mobile number. You can email. You can also see additional resources on my website, which is perrysolutions.com. I also have a quarterly newsletter I put out. If you'd like to be part of that, shoot me an email for that. I can add you to that distribution list for the newsletter, right? And it's a short one-pager. I do sometimes software reviews on different tools, book reviews, just current trends, things I'm hearing, decision-making issues, things like that. Maybe it's a tool, just a lot of things, but it's just compressed into one page. It's that quarterly newsletter, and I've archived them. I've been doing them for over 10 years now, and they're all archived on my website as well. Under the publications section, you can find that. So again, a lot of resources, and at this point, we'll open it up for questions that you can have.
Okay, really good.